Hi students, today's lesson is going to be on inequalities. So you'll be able to solve and then graph solutions for inequalities on a number line. All right, let's get started. So inequality symbols. If you haven't forgotten it, let's go through them really quickly. So the greater than symbol is when it opens, is when it opens up on the left side. Okay, so greater than means that the greater part of it is on the left side going left to right. So if you're looking at it, 8 is greater than 2, something like that. So that's why the number on the left is going to be greater than the number on the right. And when this happens, it's an open circle because you're not including 8 in the solution set. Okay, so when you have like a variable here, it's not including 8 in it. The less than symbol goes the other way. The smaller number is going to be on the left side, and this also is an open circle when you're graphing. When it says equal to, that's when you write the little line on the bottom that's saying greater than or equal to. Okay, same idea. It's opening up onto the left side because the larger number is going to go on the left side. And this is going to be a closed circle. Less than or equal to goes this way. And it's also a closed circle because there's an equal to on the bottom. So like that just means that like it could be 8 is less than or equal to 8. Okay? Or 7 is less than or equal to 8. Because that's just what's making it true. It's that number, it can be a solution to the inequality for the set. All right, select the inequalities that include 0 in the solution set. So what that means is you're checking to see if 0 will create a true statement at the end. So you're going to substitute 0 in for x. So you're going to have 2 times 0 plus 3 is greater than -4. And now you're going to simplify this. Simplify all of it. So 2 times 0 is 0 plus 3 is greater than -4. 3 is greater than -4. So this is a true statement. 3 is greater than -4. That is a solution. 0 is a solution, okay, to that inequality. Let's try another one. 5 times 0 minus 1 is less than 1.5. And now let's simplify it. 0 minus 1, 0.5, -1, 1.5. And its -1 is less than 1.5. This is also a true statement. Let's do another one. So 0 minus 5 is less than or equal to -5. 0 minus 5 is -5. Now let's look at this, okay? You have a -5 on the left, you have a -5 on the right. Is this a true or false statement? Well, because of the fact that we have this line underneath, that means equal to. So -5 is less than or equal to -5. And this is true because -5 is equal to -5. So that would make it a true statement. If this wasn't here, this would be a false statement. But because that equal to is there, that makes it a true statement. Okay? And the last one. 1/2 times 0. 1/2 times 0 is 0. Less than 0. Okay? And this is a false statement because 0 is not less than 0. It is equal to, but without that equal to symbol underneath, it is going to be a false statement. How about you pause this video and try this on your own? But this time I'm just saying include 4 in the solution set. All right, welcome back. Let's check to see which of these inequalities 4 is a solution set for. So 4 minus 6 is 9. 4 minus 6 is -2. Less than 9. That is true. -1. Oops. 3 times 4 plus 8, negative 1, greater than 12 plus 8, negative 1 greater than 20. Negative 1 is greater than 20. This is not a true statement. This is false. So that is not going to work. Negative 1 is not larger than 20 on a number line. It's not more right on it. Okay. Another one. 5 times 4 is 20. So what is that inequality symbol telling you? Remember, that means it's less than or equal to. And because of that part of it, this part of it, this is going to be a true statement. 20 is equal to 20. It's not less than, but it's an or statement, less than or equal to 20. And one more. So 3 plus 2 times 4 is 11. 3 plus 8 is 11. 11 less than 11. True or false? This one's a false. Without that equal to, it's a false statement. Okay? That is not a solution. 4 is not a solution. All right. Graphing inequalities. Solutions to an inequality can be graphed on a number line. 4, less than or equal to, use an open circle. Okay? Open circle. Maybe I'll write the open circle to graph the inequality. So for instance, x is greater than or equal to negative 1. When I ask for graphing, okay, if you're working with Ms. Patel, I'm asking for 3 numbers. You can put that number that they're giving to you in the middle, and then I just want one number on to the left or to the right of it. So this has to make sense on a number line. On a number line, the number to the left of it is negative 2. Remember, when you go left, the numbers are getting smaller. And to the right of it, it's 0. Now this is telling you it's a greater than symbol, so it's going to be an open circle here. Okay, and this means that it's going to be graphed to the right. Right. And if you're not sure which part to shade in, try to put a number in for x that'll make the statement true. For instance, you could put 2. 2 is greater than negative 1. True statement. Which side would 2 be on? Positive 2 be on? To the right or to the left? It would be on the right when this number line goes on forever, so you're shading in that side. Same number line here, okay, as far as the numbers, because the numbers are the same. So negative 1, 0, and negative 2. Open circle, because there's no equal to on the bottom. And this time you're shading it to the left, because you can put a number in here. And what's a number that's smaller than negative 3 that would make this true? Negative 3 is less than or negative 1, and negative 3 would go onto the left side. This is really important. This is why number lining helps. Right. For less than or equal to or greater than or equal to, use a closed circle to graph the inequality. So let's draw a number line. I'm going to do it black, and I can't not draw straight lines today. Let's try it again. Nope. Right, that's much better. So negative 1, 0, negative 2. And let me just draw the other one down here too. Negative 1, 0, negative 2. All right. Let's graph this one. So you're going to do, this time it's a closed circle. So x is greater than or equal to negative 1. Same idea here. Don't use an equal to, because we know that's part of it. But you can still use the same numbers to make sense of this. And 2 would be around here. So we're going to shade in to the right. Okay. Over here, you can put negative 4 is less than or equal to negative 1. Close circle on negative 1. And negative 4 would be somewhere around here. So shading in to the left. All right. Whoa. So solving inequality is the same as solving an equation, except you switch. You flip the inequality symbol when multiplying or dividing by a negative number. Not just multiplying and dividing by a number, it has to be a negative number. So for instance, this example over here, when you solve it, you're dividing by -2 by using inverse operations. So you're going to end up getting x. These would go away. And because you're dividing by a negative, you're flipping the symbol. That's the only decision. It's not every multiplying and dividing. If you're dividing or multiplying by a positive, you keep the symbol the same. But when you're multiplying or dividing by a negative number, you have to flip the symbol. And by graphing this, let's just graph it anyway. So we have -2. I'm going to put a -1 to the right and -3 to the right. And because there's no equal to sign underneath, this is going to be an open circle. Nope, I just filled it in. Open circle. And it's a less than, so it's going to be shaded to the left. And if you're not sure, just check it out. You have -3 here. Is -3 less than -2? True. That means you shaded in the right side. Okay? Solve the inequality and graph the solution. All right. So -4x plus 7 is less than or equal to 19. So we're doing our same thing, subtracting 7. I'm going to treat this like the middle of it, okay? But it's not going to be equals anymore, so I'm just kind of drawing a dotted line. So -4x is less than or equal to 19 minus 7 is 12. Divide by -4 because this is multiplication. So x, because we divided by a negative, we got to flip our symbol. You still include the equal to sign. We just got to flip our symbol, and that's going to be -3. And now let's create our number line and graph. So -3 in the middle, -2, -4. And because of the equal to sign, it's going to be a closed circle. And this is a greater than or equal to, so you're graphing towards the right. And if you're not sure, test out a number that makes sense. What number is greater than -3? It could be anything. 0 is greater than or equal to -3, and 0 would be around here. Okay, so this is the right side. How about you pause the video and try these two problems on your own? Okay, welcome back. So I'm just going to put a dotted line here, knowing that's the two sides of the inequality. We're going to add 4 to both sides. So x over 2, these go away, is less than or equal to -2. So you're dividing here, so you're going to be multiplying by 2 to both sides. So x then is less than or equal to -4. Did I forget to flip the symbol, or do we not flip the symbol in this one? Well, in this one, we multiplied by a +2, not a -2, so we actually keep it the same. All right, so no flipping in that one. So -4, so I'm going to put a -3 here and a -5 here. Okay. This is an equal to, so it's going to be a closed circle. The less than or equal to, so that means you're shading to the left. My shading leaves a lot to be desired. All right, let's do this one now. I'm going to draw a dotted line here. And on this side, the variable's on the right side. So we're going to subtract 15 from both sides. So you're going to get 9 minus 15 is -6 is greater than -3x. Divide by -3. 2 is, I'm just going to put an x. These go away. Do we flip the symbol here or not? Yes, we do, because you're dividing by a negative. So we're going to flip it around. So it's going to be 2, 3, and a 1. And an open circle. So I'm using red, so an open circle. So this is where kids get confused. They're not sure which way to do it. They have a lot. I've had former students that struggle when the variable is on the right side. What you can do is rewrite it with the variables on the left side, but it's not an equal sign. You got to make sure you flip that symbol if you rewrite it. You can't just leave it the same. Or the other option is, because this is all about shading in the proper side, make this inequality statement true, meaning that what number can you replace that x with to make it a true statement? So like you could put a 3. Okay, 2 is less than 3, and because this is the part of the solution set, you are shading in that side of it. All right. How about you pause the video and try these two as well? Right. Dotted line here, so subtract 5. So 4x is greater than 16. Divide 4. So x is greater than 4. So 4, 5, and 3. This is an open circle because there's no equal to sign here. And if we're using what I talked about just the last problem, if you're not sure which side is shaded, 5 is greater than 4. That's a true statement. And 5 is over here, so you're shading in the left side. All right, we're almost done, I believe. So we're going to do the dotted line again over here. So add 6. So 1/4 x is greater than or equal to 3. Multiply 4 to get rid of the denominator to both sides. You're going to be left with x is greater than or equal to 12. And I didn't flip the symbol because these are positive 4s. And let's graph this. So 12, 13, 11. This is going to be a closed circle because of that equal to sign. And if you're not sure, let's just test a number. 15 is greater than or equal to 12. That is a true statement, and 15 would be somewhere around here. So that means you're shading in this side. Okay, your ELA is completing these 3 problems. Write it in your notebook. All right, bye everyone.